Welcome to the 2015-2016 lecture series. For those of you that don't know, my name is Scott Schall. Jim, could you please be quiet? Thanks. My name is Scott Schall. I'm Associate Dean here at the College of Architecture and Design and Associate Professor. Tell him I said hi. It's my privilege to kick off the lecture series. Before I do so, I'd like to thank the members of the committee, the members of the faculty, and the students who submitted names forward, nominated folk to be a part of this year's lecture series. The lecture series itself and the exhibition series are centered around the thematic of the academics and the civic realm as a nod to the fact that, well, we're building something rather important, I think, on Midtown and are about to have a foot in Detroit and a foot in Southfield, which represents a fairly significant move, I think, for the college and for the university. And so this lecture series is loosely based on that movement, some of the questions and the provocations that might come from that move, which is, I think, something to be considered carefully. And so with that, as a brief and very poor introduction to the lecture series, I'll do a slightly better job introducing my colleague. Ralph Nelson, for those of you who don't know, is an associate professor here at LTU. He spends his time up on the bridge, up there masterminding the arc engineering curriculum, refining it, fine-tuning it, polishing it, and it's become something fairly great. The arc engineering program is winning awards, it seems like, daily. I don't know how they enter all the competitions to win the awards, but they do it somehow. The students all appear rather well adjusted. Which is great. Most of them are quite knowledgeable. So Ralph, that's all testament to your work. He's also a practicing architect, registered architect, founding principal of Loom. Loom features creative work that tries to use minimum means to maximum effect. I hope that some of the work today that you're going to see is from Loom. I know that several pieces are in the permanent archives, permanent collections of museums, including the San Francisco Museum of Art, as well as Cooper Hewitt. I know you've won awards, three Progressive Architecture Awards, an R&D award. I say all of this because he won't. The thing I want to end with is more on the character of Ralph, in that he is not one to give that kind of grand entry, boastful introduction. He assumes a kind of a very humble posture, but the man is bringing the goods. I make it a point, I don't think I've taught a studio yet where I've not invited you in at midterm, because I can count on Ralph to be insightful, gracious, and incredibly creative every time he comes through the door. And I think you'll see that in the work here today. I'm hopeful, I'm confident you will. And it's one of the things that brought me to LTU. Ralph was one of the first faces I met, the first people I met, and I can tell you it was a fantastic first impression. So with that, Ralph, please.
Thank you, Scott. I am so awesome. I had no idea. I'm not going to talk about my own work tonight. In fact, I'm going to start the lecture by telling you what I'm not going to talk about. I'm not going to talk about cats. But Margaret and I have these three. I also am not going to talk about the book that just came out that Jim Stevens and I spent 3 years, labor of love, working on, also in collaboration with several faculty and students here in the college. And I see a couple around here, Ergus and Andrea, and I don't know, too many people to list. And I don't know, is Lil here, Lillian Crum? Maybe not. Lil worked on the book design, which they did a fantastic job. So this book, Digital Vernacular, is something that Jim and I had been stewing on for several years and finally put forward the effort to do. It basically is a book about architecture and design that looks at timeless principles of vernacular design and joins them with contemporary digital tools for design and fabrication. So it kind of looks to the past, engages the present, and projects a future. And we think of digital vernacular as both a way of working, but also a way of describing a particular type of outcome in architecture. So I also am not going to talk about my practice, although the middle image is an image of a project I'm working on right now in St. Paul. I started my practice way back in the 20th century. Called it loom because I'm really interested in weaving disparate things together to form an integrated whole. And I thought loom as an apparatus, a mechanism for weaving would be an appropriate title. So the project in the middle, and actually Ergis Hoja has been helping me with this, it's a 20,000 square foot space. It was an old can manufacturing facility. So there are 4 partners who are actually turning it into an arts, a kind of multi-purpose arts center. And they'll have food. There's 2 bars, a hard bar and a soft bar where you can get ice cream. There are 2 theaters, a large multi-purpose, and then a wee theater for kids. And one of the features of the whole outfit is an 18-hole miniature golf course, indoor miniature golf course with what will be the world's longest miniature golf hole, 208 feet. So we're looking forward to that. And then it also has a video arcade, which essentially will have old-time pinball machines as well as virtual reality games, contemporary virtual reality games. So I have always done 1 or 2 projects a year in practice, and I just love doing a wide range of projects. For me, any project I take on is fun, interesting, but anyway, that's an image of the current one. So, and the last thing I will not talk about tonight is golf. Although I absolutely love golf, and for me, golf has a strong relationship to design in that it's a game you play with the earth. It's a game that requires you to really be in the moment, but have a sense of the past and also projecting towards the future. It's a game you can never perfect. Believe me, I've tried. You can never perfect it, just like design. And it also requires multiple iterations and a lot of improvisation. So anyway, that's what I'm not going to talk about tonight. What I will talk about is design. I've been doing it for several years, and how design somehow has a strong connection to processes of evolution and forces of life. So what is design? I'll throw out, I don't know, a few definitions of design, but in the context of evolution, design is a series of incremental changes over time that leads to particular outcomes. Design in relationship to life, well, design makes life vivid. That's one of the roles of design. Now, design also, I think, comes from life, comes from all the forces of life. And if we think about the forces of life, they've gone through processes of evolution. There's 100, 1,000 different processes you can use for design, but for me, evolution is the one I always connect with. It works for me. It's because I just think it comes out of life. Relative to design, if you think about life as just being a scavenger hunt, I mean, shouldn't design be that? Isn't it just the opportunity to just find whatever is out there in the world and start to get that stuff to work together? I mentioned earlier about golf, past, present, and future. For me, the best works of design are those that are designed for the present, like being fully in the moment, responding to the moment. But I also think all good design comes out of a deep awareness of the past, a sense for history, a sense of where things come from. Now, some architects, some designers, like all their stuff looks like the past. They're just kind of replicating the past because they think, all good things have been done and they're finished with it. But I that's not me. I design for the present. A lot of designers, architects design for the future. So they're always thinking about the next new whiz-bang thing, and we're going to live on Mars and do fantastic things. And I have no problem with it per se. It's just not for me. I don't want to live on Mars. I don't think you really can. But I'm just more interested in design that can respond to the intensity of the present while understanding that the present is just the past that's moved forward in time. And if you're going to project a future for architecture, you're just taking it a little bit forward into the future, a little bit forward in time. Well, the last image up there, everything is interesting. Personally, I find everything interesting. I'm never bored with anything. I never find anything dull or, well, some things I find dull and stupid, but for the most part, there's always something interesting in everything that exists. And as an attitude and approach to design, to good design, for me, I think that's really important. Let me talk about a few of the hundreds of people that have influenced me, or ideas that have influenced me, but certainly over my career. The guy on the left is David Pye. It's kind of a nerdy Englishman, sort of looks like me, unfortunately. But he was a great craftsman, an educator, a design theorist and critic. And one of several of his fantastic ideas that are put forward in a book called The Nature of Design is this idea that everything flows. So design is about connecting to the flow of everything. All you're doing is transforming one energy and substance into another. But you need to be connected, because everything flows, you need to be connected with the larger systems that your design work is going to be a part of. And if you don't connect with those larger systems and that flow, that transfer of energy, you're just missing half of what design has to offer, half of the good things it can offer. David always said that every design is flawed. Nothing can be perfect in design. He just considers works of design to be an improvisation, a lash-up, the best you can do in that situation at that moment. And for me, I don't take that as being pessimistic. He's English, after all, so he has to be pessimistic. But it sort of gave me the freedom to not be worried about making great design and just kind of allow myself to be part of the process and activity and be intelligent about it and let the good design emerge out of that process. The middle guy, anyone know who that is? Niels Bohr, famous physicist, scientist of the 20th century. Love Niels Bohr. I like science in general, just for a number of reasons, but, well, so the quote there, I think is important only because he had this sense that the world, the universe, physics is more remarkable than we can ever imagine. And you got to really have crazy ideas that ultimately are related to the facts of physics or the way in which the world operates. And one of his most impressive quotes that I think about relative to design, he said, the task of physics is not to say what nature is, rather it's what we can say about nature. So for me, design is saying something about life. And what I like about it too is it's like he has a kind of humility in that statement, right? It's not arrogant, I know what nature is. It's really, oh, this is what I can say about nature now. The last guy, anybody know who the last guy is? Jim Jarmusch, exactly, filmmaker. Always loved his films. I mean, I like artists, I love artists. Jim Jarmusch. Jarmusch. Yeah. So I don't know if you've ever seen any of his movies, Down by Law, Stranger Than Paradise, Mystery Train, Broken Flowers, fantastic films. So what I love about Jim Jarmusch is something he said about theft. And I'll quote him. Nothing is original. Steal from anywhere that resonates with inspiration or fuels your imagination. Devour old films, new films, music, books, paintings, photographs, poems, dreams, random conversations, architecture, bridges, street signs, trees, clouds, bodies of water, light, shadow. Select only things to steal from that speak directly to your soul. If you do this, your work and your theft will be authentic. Authenticity is invaluable. Originality is non-existent. And don't bother concealing your thievery. Celebrate it if you feel like it. In any case, always remember what Jean-Luc Godard said, it's not where you take things from, it's where you take things to. So I'm here tonight to promote thievery in design studio, in design, right? Now don't steal someone's laptop or anything, but personally, I've spent my whole career not really inventing new things, but being a great student of history and quote unquote stealing from everything that already has existed. And all I do as a designer is just put existing things together in new ways that have not been put together before, and new things emerge. But I don't spend much energy trying to invent new things. I spend much more time and energy trying to learn about what already exists and engage that directly. I do see a lot of students, a lot of practitioners of design spending a lot of time and energy trying to be different, when really I think you should be spending time trying to engage the origin of things, because that's your source material. If you're only trying to work in your head, I mean, your head is super limited, right? The world is much bigger than your head. Engage the world, and great ideas will come forward. If you're just working in your head, I don't think so. I love Oscar Wilde's quote, "Be yourself, everyone is already taken." Let's see, Jim and I both have an interest in vernacular architecture, and that's how digital vernacular came about, but I have ever since I started having an interest in architecture and design, I've always been drawn to vernacular design, vernacular architecture specifically, for a number of reasons. One, I think, is just there's a kind of directness and authenticity of expression. There's a humility in the work of vernacular architecture, but there's also a kind of dream factor. It's like, okay, given the available resources we have in a particular place, what can we do? How can we express our intelligence, our creativity? How can we be in sync with the nature of the place, the forces of nature that surround the site of the architecture? And I've visited all of these places and hundreds, and if not thousands, of other works of vernacular architecture, and for me, it's some of the most powerful design ever created on earth. I have no idea what particular person did this. I know Frank Gehry didn't do any of this, or any of these other big name architects. And it's not that I don't appreciate like star architecture. I mean, there's some fantastic buildings being done. It's just my sensibility, my heart registers with the vernacular so much more. And in part, it seems to me that it's based on ideals that are fundamental to life on Earth, fundamental to humanity, fundamental to the way people come together socially, the expression of unique cultures. For all those reasons, I think vernacular architecture is still an outstanding expression. I've always considered myself just a traveler, if not an explorer of the world. I just try to put myself out in the world and engage it in any way I can. And I always recommend to students that you do the same. Just have a huge appetite for life and engage it fully. Be observant. I think something that's really important is to start to notice patterns and make connections between things. Another definition of design, I think, is design is the art of defining relationships, defining connections between things. It's not the things themselves that matter, but it's the relationships between them that matter for design. If you're out there in the world and you want to, I don't know, eat it up, I think it's important, and these are bad representations of this idea, but I think it's important to really think big picture in the world and think about how that might influence design decisions that you ultimately will make. So just knowing whether a place is mostly hot or mostly cold, or whether people can live on $1 a day, or who leads the world in what? I mean, I had no idea that Russia led in raspberries and nuclear warheads. And what is it? I think, what is Australia? Cricket and melanoma is Australia. Anyway, I mean, the facts are funny, but they're also facts that have deeper meaning and a broader, larger scale that ultimately influences design decisions. So thinking big, looking at a large scale, I think is critical for design, whatever you're designing. Now, I think it's also super important to look at the small scale, micro scale. And I guess this kind of goes from micro scale to a macro scale. This, to me, is a diagram for design. One project or many projects. What is it? Just basically like mutations in the evolution of a particular organism, right? And over successive time, mutations create variations. Unfavorable mutations are selected against. Reproduction and mutation occur. Favorable mutations are more likely to survive. The middle one shows basically, like 3 different lines of life, but what's really curious is this thing called horizontal gene transfer. And I'm not a biologist or anything, but this idea that genes from certain organisms transfer to other organisms, and especially bacteria in that diagram are responsible for affecting plants and animals and single-cell organisms, and the way those genes and DNA develops. So this whole idea that natural evolutionary process of gene transfer could parallel a design process where literally ideas transfer from one thing to another seems compelling to me. And the one on the far right basically just illustrates that idea in a slightly different way, but it's 3-dimensional, which I think is interesting. So this idea that there are origins to all the different living things, and those origins intertwine, duplicate, replicate, mutate, transform into all the different things that are in the world today. And so again, all of these for me are design diagrams, design process diagrams. Now, not only do we have this operating in what's considered to be kind of natural evolution, and the middle one, butterflies, it's a kind of natural evolution process. And the far right is something I'd call selective evolution. And it's a kind of weird hybrid between people being involved with natural systems. So, all these different things, Brussels sprouts, cabbage, cauliflower, they all come from wild mustard. And basically when people started interacting with wild mustard, they got the wild mustard to move in one direction or another, depending on the qualities or features that they identified as being positive, something that was desired. And, really all of our contemporary agriculture uses this process of design. I just find it fascinating. Things that are maybe not involving the natural world, but are designed, have this same evolutionary process. So on the left is basically the development of the web. In the middle is the development of architecture and all these cross-fertilizations and overlaps. And then the evolution of bicycles on the right, which, you can see that there's a common origin, but there are all these variations, all of which respond to one force or another, one condition or another, one context or another to create difference. Same thing for politics on the left. That's the whole history of the U.S., the political intertwinings, art in the center, and then the far right is just a diagram of architecture schools in the U.S. and how those big blobs are basically schools of thought when architecture schools started, and then the different lines moving forward and the crossover, the horizontal gene swap, based on which faculty or which individuals went to different schools or participated in different schools. So these are how ideas are formed. This is design evolution, I think. Now I always look at, or I always use DNA as a metaphor or analog for design. And every time I think about design, I think, okay, what are all the bits and pieces of information? What's all the stuff that I have to work with on a particular project? What's available to me? And how do those things get organized? And ultimately, how can I take many disparate things and figure out how they can relate to one another? And when they conjoin, how some new thing can emerge. So the image on the far right just shows chromosomes for a normal male. Well, what's the outcome for a normal male if this is natural evolution or selective evolution? Well, here's 3 alternatives. So it's a normal male on the left, normal male in the middle. 99% of their DNA is shared. It's just that little 1% or 0.1% that makes all the difference. And I think about design like that, too. Now, the image on the right is actually selective evolution. These would be considered natural evolution. But design is just selective evolution, right? You're choosing what things get combined to form a new whole. Okay, so here's 3, I just pulled these off the internet, 3 diagrams that define different processes for, I guess, 3 different disciplines. So I love engineering, and I love engineers. I love them in part because they're inclined to measure everything. Like measuring things validates things. I think that's pretty important. I also love art and artists in part because it deals with the unmeasurable, which I think is also really fundamental to life, right? There are just so many, what's a measurement device for love? But yet it's so fundamental to just our life. Engineering diagram, one criticism, well, 2 criticisms. One is that it's typically based on a problem solution model that circles around itself. And okay, one, I don't believe there are really any problems. And I certainly don't believe that you can solve problems. I believe you can address some issues and you can make a response that alleviates trouble or the bad, but I don't believe in the problem solution model for design. And not all engineers, but certainly that's been the conventional logic behind an engineering process. In the middle, art, again, this art process is fine. It's a little more nebulous, touchy-feely. There are tones and shades of hue. But fundamentally, art is so much about self-awareness, self-expression. And both these diagrams, you'll notice they're circular around the discipline. I feel like oftentimes art and engineering are too focused around the discipline itself, not what's going on outside the discipline. Like, okay, if you have a design problem in engineering that needs to be solved, the answer is going to come from engineering. And same thing for art. It's like you're making new art, okay, it's going to come from art. And personally, I think that's just the wrong diagram for an appropriate process. Now, the process on the right, which is design, and I modified it a little bit. So instead of the problem solution or the self-reference, self-expression, for me, it's all about identifying this particular situation or grasping a particular situation. And ultimately, at the end of the process, you have a response. And instead of a circular, self-centered kind of process, it's more like an intestine, right? You're feeding it, things happen, stuff comes out the end. And in a good design process, you want more of the green stuff to come out than the red stuff. Now, I said I was going to talk about design, evolution, and life. So I'm going to try to illustrate all the ideas I talked about previously with the Living Building Challenge and then a project that I worked on with some students this past spring. So I don't know, how many of you, raise your hand, how many of you know about the Living Building Challenge fairly well? So, okay, there's a good number of people. For those who don't know, just brief summary, for me, it's a set of principles and a set of standards for design that I think, well, it's a set of principles and standards that suggest that anything you design, certainly any building you design, just needs to participate in systems of life, both natural and cultural, that are sustainable and support those life systems, aren't antagonistic to those life systems. And they have something in the Living Building Challenge, and believe me, I am not one to like join a club or be a spokesperson for the Living Building Challenge, but it's just, It's something that exists in the world that seems to me to be pretty smart and based on common sense and based on a future for all of us. But this idea that there's 7 petals: energy, place, equity, beauty, materials, health and happiness, and water, that those things are all fundamental to life. Certainly human life, but all life in a way, although I don't know if broccoli is happy or there's equity for tigers, but I think it certainly should be a part of all life. We use the Living Building Challenge in a studio I led with some graduate architecture engineering students this past spring, and also for the group that I'm working with right now. And we use the Living Building Challenge in an attempt to design for life. And the project that this is actually for a competition, and the project was for a 50,000 square foot addition to an existing urban farm in Milwaukee, Wisconsin. And under the Living Building Challenge, we had to be net positive with energy, net zero with water, waste, and no red list materials, in addition to having a sense of beauty, fostering health, happiness, equity. I'll explain, hopefully, ways in which we address those, and also the evolutionary process that we use for the design. So this is just a view of the proposal from the street. So the site, the context was this wonderful, kind of unruly existing urban farm in Milwaukee. It's actually run by Will Allen. Anyone heard of Will Allen? MacArthur Genius Award grantee, amazing individual. They have, and this is mostly what it looks like today, but they wanted to add a building in that big chunk of space up there. We took a trip there because we didn't really understand the institution or what Will Allen was about, but certainly we didn't understand the working operations of the farm. And what we found was a number of remarkable things. One, it was all vernacular design. It was like, okay, how can you be the most intelligent with the least amount of resources? How can you, get the maximum from the minimum? But there was this sincere sense of equity, diversity, and joy in the place. They practice in the far right aquaponics, where basically you have these long, long fish tanks. Plants are integral to the fish tanks. The fish eat the plants. The fish waste feeds the plants. It's a closed loop cycle. But just the fact that they were doing this, practicing this, and actually successfully selling the fish and the plants seemed pretty remarkable to us. So part of the design process was trying to take at least a broader view of what are the available resources in this case, I think it's a 500-kilometer radius, especially in terms of building material and labor, looking at Milwaukee and some of the shipbuilding history, steel history, other things that were related to Milwaukee, and also understanding the neighborhood on the far right, which was primarily a series of single-story residential properties, a couple of industrial properties. There was a military base just to the right of the site, the east of the site, and a large state forest and a stream that ran through the site. So we're trying to figure out, okay, how do we, this is the physical situation that we're given, how do we respond? Now, with this competition, they basically give you what's called a base building, and in this case, it was a 5-story vertical farm. Greenhouses on top, educational and market spaces below. And when we were given this base building, we had the option of redesigning it or taking it as is. We felt like a 5-story building, one, just looked like a skyscraper in the middle of flatland. Two, cast these giant shadows over the entire site, which basically would prevent sunlight from getting into the other greenhouse spaces or hitting the animals or anything like this. So when we reconceived of how we might design, we proposed a 3-story building that would actually work with the grain of the greenhouses that exist, and then also, as we reorganize the site, find a place for future greenhouses and all the goats, including the bucks, the does, and the kids, as well as the chickens, the work yard, and all the growing spaces, including a compost yard, which was pretty important. And then we just assessed what the soil could give us, what the sun could give us, what the water could give us, and what the wind could give us, or I shouldn't say give us. Those were available resources. How could we connect with those, channel those, make them part of the design? We did look at vernacular architecture, industrial greenhouses and barns in particular, but we also looked at the Kimball Art Museum, which essentially was designed in response to this Fort Worth State Fairground cattle barns. So it kind of had its origin in vernacular design as well. And we decided to, well, we recognized that some of the virtues of the Kimball Art Museum, two of which were integrated space and structure in these elongated bays of space, but also the clever way in which all the mechanical and electrical systems and daylighting were integrated in the building. So what we did is essentially just do some speedy evolution. We hybridized the Kimball Art Museum with the program of the base building and then vernacular barn greenhouse structures. And so the plan on the right is essentially our new work of design, our little animal that evolved, that works with qualities and principles of all three of those things. So just a brief orientation to the building itself. So on the north end at the lowest level, the basement level below grade, on the north end, that's where all the waste heat and cooling is kind of channeled. Center is storage and a central stair, and then there are water tanks that are on the south end of the building. You kind of see the same, you can see how that plays out in section to the right. So on the main floor, there's an entry that basically takes you on a bridge past the water tanks, which basically collect all the water, and you come in through what's called the solar arcade. You immediately see the central stair and exhibit area and what's called the living wall. So the living wall is actually the breathing apparatus of the whole project. There's a market that fronts the street, and in the back, support processing workshop. There's a very important thing on the north, which is the compost house. I'll get to that in a little bit. And then parking and loading dock on the side. On the second floor, so in section you're stepping back and stepping up, there are classrooms, demonstration kitchen, and a large gathering space for 400 people, as well as on the south, a full extent of 3 greenhouse bays. On the very top floor, double greenhouse bays flank office space in the center, and everything's oriented primarily to the south, but also east-west. See, the living wall travels all the way up the whole building. So one of the first things we had to think about was how we can actually structure this new building. And we looked at a number of different vernacular as well as non-vernacular options in concrete, wood, and steel. And in the end, we selected a steel system based on pre-engineered, prefabricated steel portal frames, particular type of steel structure. And we selected it in part because it's super economical. All the sections basically use the least amount of steel to do the most amount of work. And the profiles all allow the form to follow the force. Essentially, no material is wasted because you got more material where the forces are greater and less where they're smaller. So the students make this analog that a tree in nature operates the same way, right? Let's see. And I guess the innovation was actually figuring out structurally how you can stack these portal frames for a building. One of the advantages, you get these nice long span spaces. You can vary the height. You get super conventional connections. Also, the design has this modular aspect, so you could actually do a 5-story building with it that's tall but has smaller footprint. You could do a medium density site, maybe 4 stories, and ours is a low density site, so bigger footprint but lower in height. And also, by opening up gaps between these frames, you get these vertical shafts and channels for distribution of air, water, electricity, all kinds of things. You get some of the interiors, again, these broad open spaces, so you can get copious amounts of daylight as well as weave all those systems through. One of the really interesting things is the way the structure is organized all the way up to the roof. The building can essentially capture all the water from the roof and, just like a waterfall, send it naturally all down to the collection point right at the entry of the building. So literally when it's raining, you're coming through into a waterfall, and you can see where the water is collected. The structure also had to respond to forces of wind, in this case defining the lateral bracing so that you can literally register the wind force in the building. But we also use wind for natural ventilation as much as possible so that the building can breathe on all 4 levels. And we also use wind to produce electricity, part of the power of the building. And even though it seems kind of simple in this drawing, but figuring out that 6 wind turbines and 6 wind turbines of a particular configuration, a particular height, was part of the engineering challenge that they had to figure out. Now, it's also there's a huge PV array that's part of the building, and one of the main features is the solar arcade, which is essentially this kind of major entry space for the entire building. And it exists for 2 reasons. 1, to hold more PV panels. 2, to be this kind of porch to the neighborhood, this gathering space for the market, connecting to the urban fabric. And the PV panels ultimately were sized to meet the goal of a certain performance of energy, but we also sized it up, so in the future, if they add more buildings, increase the load, that can be accommodated. Solar arcade entry was also, had some interesting structural material variation. So in the far right, there's a company called Whole Trees in Wisconsin, and they basically take whole trees and with minimal processing use it for structural purposes. Now the good thing about trees is they come in all kinds of different sizes, lengths, dimensions, so you can actually select the wood to meet the structural need and not have to be redundant about the structure. And we just thought it was a really interesting way of weaving in the local economy, local material, local process to a structure that, you know, potentially could be in other locations. And it just made the solar arcade a variation on a theme. Ultimately, wind produced, we ended up with a net positive 118% energy, so we're actually producing 18% more energy than you need. Part of the reason is over time, PV and wind turbine, they lose efficiencies, so you have to overcompensate. And the reason why wind power is a greater source of energy than sun is because the sun doesn't shine at night, but wind blows. Now, one of the most innovative things, and again, this is all about connecting with natural systems and understanding actually how they can be integral to a building. One of the greatest innovations, I think, was identifying that the natural compost that they need for the farm operation actually is just heat ready to be utilized for something. So compost, usually a big heap of compost will have an interior temperature of 150 to 180 degrees for a pretty extended period of time. So working off of someone else's idea, someone in New Hampshire came up with this idea of harvesting that heat. We developed a strategy for sizing and staging the compost, and in the section on the right, the entire building is heated just from the latent heat of compost, stuff you already have to have on site. Which I don't know how many full buildings are heated with compost, but I thought that was pretty cool. Because usually you got to burn something, right? Burn gas or use electricity or something like this. All the cooling is provided by shallow geothermal loops that are placed in part under the building and also an extent of the site where deep excavation would never be required. So essentially when it's way too hot above grade, the natural cooling of the earth allows the whole building to be brought down to a reasonable temperature. Now, every building has to have, especially assembly building like this, your you have to provide fresh air, right? Because everyone likes fresh air. So usually, fresh air is provided by a unit that takes outside air and either cools it down or heats it up and then puts it in the building. Well, there's a big loss of energy for doing that. Working with an existing system that someone else invented, but figuring out how to modify it for this design, we use something called a living wall, which is literally a system of plants and a series of manifolds that use the plants almost like an air filter. Not almost, they are an air filter. So all the people in the building and the air, especially the carbon dioxide that you give off when you breathe, the plants love carbon dioxide. So they draw that through, they cleanse the air, and what comes out the other side is clean air with oxygen, because that's what they're giving off. So you don't have to temper any of the fresh air, because it's not coming from outside, so you don't have to heat it or cool it, but it gets to that, it meets the ventilation requirements for the building. Plus, it's pretty cool to have plants in the building. So the main feature of the building has the stair and the living wall integral, so anytime you go up or down in the building, you're always connected to that. All the ductwork then is integrated fully and woven through the structure. It's all expressed so people can actually see how the building operates. It's not a mystery like in most buildings. And another cool thing about this project that in a typical building you have an air handling unit, just you size a bunch of them for the space you need, just bolt them down to the top of the building, and the air handling unit heats, cools, and provides fresh air. Well, in this case, they ended up in the system that they set up, the whole building was its own air handling unit, which, I don't know, maybe it doesn't seem cool to you, but it's pretty cool that the building itself is that unit. Daylighting was a big part of the design for obvious reasons, not just for energy, but really for happiness, health, beauty, and that was integrated with all the electric light systems in the building. And same thing for just the electrical systems, like the mechanical systems, woven through, in this case, conduit was colored and expressed, so you can actually see which type of circuit is traveling where, what's for safety, what's for power. And then the water system. So all the water that comes to the site can be used on the site, and what isn't lost to evaporation or other things can be cleansed and recycled. And then finally, toilets. So all the waste is basically composted and can be used for another purpose, but it doesn't go down a sewer to a main treatment plant. It stays on site. So for me, this was designing a building for life and trying to figure out all the different forces of life that you can connect with and make that building, or allow that building to be a part of an ecological system. Just some of the brief summary virtues of it, this idea that you can think about a structure that's flexible and adaptable and can do many things at once. I mean, who wouldn't want that for a building? Idea that a mechanical system, you can design a mechanical system that could be fine-tuned to the environment you're in, but you take advantage of the opportunities the environment gives you. And the same thing for electrical energy, that you can fine-tune wind and solar depending on where you are in the country, and also geothermal depending on where you are in the country, to allow the building to be part of its natural environment, just like a natural plant or an animal would be. I know I always show this slide when I get towards the end of talking. For me, I like regular math, and I get it that 1 + 1 = 2, but for me, design is more about having 1 + 1 = 3, or even better yet, having it equal 11. Like, you always want the whole to be greater than the sum of the parts. And if you strive for 1 + 1 = 11, I think you'll be there. So I just talked about a few things. I know in design, I said, you gotta think about everything in the world, but ultimately in design, some things are not important, and to be a good designer, you have to figure out how to edit. But your perspective means everything, your perspective on things, and you gotta be open to whatever comes next. So what is coming next? I'll finish with a little advertisement. So Lillian, Margaret, Paul, and myself, we're going to take a group of students to Paris next summer. And what? The cats, we are working on their passports right now. We're going to go to Paris, engage the life, think about design. Yeah, I guess everyone's little specialty is there. I'm curious to see what Paul has to say about poetry and philosophy. We'll give you more information about this trip coming up soon, but we look forward to having as many students as are interested. So, yeah, I think I'm done. Today, how long did I go? That wasn't too long, was it?
Time for questions.
Hey, there we go. Oh my God, that was a long time.
Good time for questions.
Yeah, I'm happy to take any questions or provocations or interrogations. Really, it just like everything was explained or nothing was explained? No comments, questions? Everyone can take off early then. All right, thank you all.